Let's look at an easier way to solve this problem using the wall, the spring, and the box as our system. This allows us to use potential energy terms which we couldn't use with a single mass system. I call it the work energy theorem version 2.0. Now we could state that the initial kinetic energy plus the initial gravitational potential energy plus the initial elastic potential energy plus the non-conservative work done equals the final kinetic energy plus the final gravitational potential energy plus the final elastic potential energy. To see the derivation of this version of the work energy theorem, watch the optional video that follows this video. Now, at the start, when the object is right here, it's at rest, so it doesn't have any kinetic energy. And if we think of the floor as our zero altitude, zero height reference level, the object doesn't have any gravitational potential energy either. But it does have elastic potential energy because that spring is compressed from its equilibrium position way out here. Now, in terms of non-conservative work, there isn't any non-conservative work. The work that the spring does when it expands is conservative work, and it's taken care of by these potential energy terms, these elastic potential energy terms. Now, let's let the animation go here. Whoa. Now, at this second point over here, you see I drew these little lines right here indicating that it's moving. It does have kinetic energy, but it's still on the same ground reference level, so there isn't any gravitational potential energy. And the spring is no longer pushing on it, so there isn't any elastic potential energy. So the bottom line is the elastic potential energy initial turns into the kinetic energy final, or we could say 1/2 kx squared equals 1/2 mvf squared. So 1/2 4 newtons per meter times -6 meters squared equals 1/2 times 2 kilograms times the final velocity squared. And when you solve that, lo and behold, you get the same answer you got before, 8.5 meters per second. Obviously, using the work energy theorem version 2.0 with the potential energy terms is much, much easier.